Before we talk about electrolytic cells, let's just do a little comparison with the voltaic cell down here. So a voltaic cell involves a spontaneous reaction. The cell potential is a positive number, and so it can do work. In other words, you can get electrical energy from it. It can drive an electrical current. Okay. Electrolytic cells are just the opposite. So that's why I wanted to put that there. They involve a non-spontaneous reaction, and you have to put the electricity into it to drive that reaction to make it occur. And this kind of reaction can be done in different circumstances. The simplest one is if you have a rechargeable battery. When you're recharging it, you are doing this. You're running it as an electrolytic cell. You're putting a current through it to get the reaction to go backwards so that you can use it later to get electricity out. It can also be used in circumstances where you're wanting to plate out a thin coat of a metal. Gold electroplating used to be done to make inexpensive jewelry sometimes, but other reasons you might need a thin coat of a metal. It can also be done to obtain a metal that is in like a salt mixture. But anyway, a few new terms. Because it requires a current, you can keep track of how much electricity you need to run in order to get the amount of plating of a metal or whatever it is you need. And electricity is measured in coulombs per second, which is basically charge per second, and we call that amps. And then, I don't know if you noted this, the potential will be negative. We know that. Let's look at an example of the kind of problem you can do. So basically, we're going to look at calculations that involve how long it takes for the reaction to get the amounts that you want. Right? So how long do you have to run the reaction? And that, of course, depends on what your current is, how fast your electricity is flowing. And so we'll use the current to get to the number of the amount of charge. And then from that, charge and moles, the conversion factor is the Faraday constant. What that is. And then once we have moles of electrons, then we can use our coefficients to get to moles of a reactant or product.